Phlogiston, mass, and the birth and demise of the force of gravity. Firstly, my apologies. I haven't published any new material for some time. I've been researching the concept of relative density, which has involved studying mass, which leads to the theory of the force of gravity. Before discussing mass and the force of gravity, it is first necessary to present the phlogiston theory in order to provide the necessary context when required. Phlogiston theory. The phlogiston theory was accepted for more than 100 years. The theory held that materials that burned contained a fire-like element called phlogiston that was released as the object burned. The main points of phlogiston theory were: all combustible substances contain phlogiston. The more phlogiston a substance contains, the better and more completely it burns. Combustion releases the phlogiston from the substance into the air. The flame indicates the rapid escape of phlogiston. There is an attractive force between the air and phlogiston. Air is necessary for combustion because it absorbs the escaping phlogiston. Combustion in a closed container soon stops because the air inside becomes saturated with phlogiston. It becomes phlogisticated air. Similarly, air is necessary for breathing. A creature placed in a closed container dies because the air cannot absorb any more phlogiston, so can no longer support life. 2 videos on phlogiston theory. Links will be in the description. The phlogiston theory. This phlogiston theory was believed and propagated by the influential scientists and teachers of the day for over 100 years between 1667 and 1770. The phlogiston theory was discredited by Antoine Lavoisier between 1770 and 1790. Antoine Lavoisier studied the gain or loss of weight when tin, lead, phosphorus, and sulfur underwent reactions of oxidation or reduction, deoxidation, and he showed that the newly discovered element oxygen was always involved. Although a number of chemists, notably Joseph Priestley, one of the discoverers of oxygen, tried to retain some form of the phlogiston theory, by 1800 practically every chemist recognized the correctness of Lavoisier's oxygen theory. Now the concept of mass and the birth and demise of the force of gravity will be discussed with phlogiston theory used as an example comparison. What is mass? I truthfully cannot explain what mass is. No one can explain what mass is. Describe, but not explain. Mass cannot be explained without using new terms and words, which then need explaining themselves and still do not explain what mass is. It can sound technical, but doesn't actually explain. Here's an example. All physical objects are made from particles, atoms, or molecules, and atoms are made from protons, neutrons, and electrons, which have mass. The statement above, although sounding impressive, did not explain what mass is. Why do protons, neutrons, etc. have mass must be explained once they have been proven to exist. What is this mass they have? As can be appreciated, this takes us back to the drawing board, so to speak. The accepted definition that mass in physics is the quantity of matter in a body regardless of its volume or of any forces acting on it. This definition is implying that mass is matter. The term matter now has to be explained, which undoubtedly will involve new unexplained terms and notions based on assumptions, and it goes on. And now dark matter has been proposed, and that can't be observed or detected. Yes, really. Mass cannot be explained without going into assumptions and suppositions. So what can be said, if anything? In the diagram 1 below, there are 2 blocks of pure gold, A and B. It is an assumption that both A and B are 100% pure. Block B contains more of the gold material/substance relative to block A. There is a greater amount more of the material substance of gold in block B relative to block A. Feeling block A and B in the hands, the relative volume difference between the two blocks can be experienced. So, for a pure substance, mass means how much is present relative to another discrete amount of that substance. Example, in diagram 2, the two C blocks of pure gold each consist of half the amount of gold relative to the block of gold D. In this example, a pure aluminum block A and a pure lead block B are being used. Pure is an assumption. Observation 1. The aluminum block A takes up more 3D space relative to the pure lead block B. Observation 2. The aluminum block A and pure lead block B are not balanced on the scales. What could be said from the observation below? The lead block B contains a greater amount of lead relative to the amount of aluminum the aluminum block A contains, but the aluminum block takes up a greater volume, 3D space. What else can be said? The concept of units. The block of aluminum can be cut up into small pieces, and it can be further cut up into smaller and smaller pieces until the pieces are too small to see and cut under a high-power microscope. The solid aluminum can be melted into a liquid, 660 degrees Celsius, and then boiled, 2,470 degrees Celsius. A solid object cannot pass through the solid aluminum, but can pass through the liquid and the gaseous aluminum. From these above observations, it can be supposed that the block of aluminum is actually made up of units of aluminum, and each unit of aluminum is very, very small and discrete. It can be assumed that the lead is also made up of units of lead. Observations of what happens when the blocks are placed on the scales. A pure aluminum block and a pure lead block of identical volumes, 6 centimeters cubed, will be used. When the pure aluminum block and the pure lead block are placed on the scales at the same time, assumption, the lead block and aluminum block accelerate in opposite directions relative to each other. When only the aluminum block is placed on the scales, the aluminum block accelerates in the opposite direction to the pan with no block on it. When only the lead block is placed on the scales, the lead block accelerates in the opposite direction to the pan with no block on it. How can what is observed be justified or explained? What assumptions can be made from the observation? What can be inferred? A series of assumptions will be made to show what they lead to. Both the pure aluminum block and the pure lead block are of identical volumes, 6 centimeters cubed. What is causing the effect witnessed when the two blocks are placed on the scales? It is assumed that both blocks are subject to exactly the same external conditions. It is then assumed that it is the intrinsic nature, something to do with the actual lead and aluminum, that is resulting in the observed effect. There is a difference between 1 unit of aluminum compared to 1 unit of lead that is resulting in the observed effect. From direct experience of holding and observing the two different blocks, it can be stated or assumed the lead block has more, is more, contains more than the aluminum block. The next question is why? What is causing this? What assumptions regarding mass can be made based on the observation shown below, assuming that both blocks are subject to exactly the same external conditions? Possibility 1. The aluminum block contains the same number of aluminum units as the lead block contains lead units, but each lead unit consists of more mass or stuff than an aluminum unit. The results in the overall total mass or stuff of the lead block being greater than the aluminum block. Possibility 2. The aluminum block contains less aluminum units relative to the number of lead units in the lead block, and each lead and aluminum unit consist of the same or amount of mass or stuff. This results in the overall total mass or stuff of the lead block being greater than the aluminum block. Possibility 3. The aluminum block contains more aluminum units relative to the number of lead units in the lead block, but each aluminum unit consists of less mass or stuff than a lead unit. This results in the overall total mass or stuff of the lead block being greater than the aluminum block. It has been assumed that the lead block has more mass or stuff in it compared to the aluminum block of identical volume. It is only an assumption that the lead block possesses greater mass or stuff relative to the aluminum block, since no mass has been physically counted or quantified. It cannot even be explained what this greater quantity of mass is that the lead block assumedly possesses relative to the aluminum block. Please note, the word mass is now being used regularly, although it has not been explained. This is because in an attempt to communicate and express ideas, words and terms are used that haven't been explained or properly understood. Unsurprisingly, this can lead to mistaken assumptions and incorrect theories. Continuing along the line of well-meaning assumptions leads to 1. The overall total mass or stuff of the lead block is greater than the overall total mass or stuff of the aluminum block. How the next point is worded is absolutely essential, as it will be shown that how a statement is worded will influence the direction the line of thinking can take from that point, and how assumptions can be formed from the way the statement is worded. 2. The dish of the scale with the lead block goes in the opposite direction relative to the dish with the block of aluminum of identical volume on when the observation is performed in the medium of air. This is factually correct and, importantly, does not include any unnecessary information that could result in the creation of unproven notions, ideas, assumptions, or suppositions. Wording point 2 differently can lead to the mistaken creation of unproven notions, ideas, assumptions, or suppositions. 2. The lead block is pulled stronger towards the ground or earth than an aluminum block of identical volume. As can be clearly understood, the wording in this statement has created a number of new suppositions and assumptions. A. The block is pulled. B. Since it is now assumed that the block is being pulled, this then necessitates the presence or existence of a force. C. There is an attractive force between the ground or earth and the lead block. D. There is an attractive force between all physical objects. E. The greater the mass or stuff of two objects, the greater the attractive pulling force between them. These suppositions and assumptions have been generated from the erroneous wording of a statement. The example of the phlogiston theory will be used to demonstrate the impact and effect of erroneous wording used in a statement. Phlogiston theory states that phlogisticated substances are substances that contain phlogiston and dephlogisticate when burned. Dephlogisticating is the process of releasing stored phlogiston, which is absorbed by the air. Growing plants then absorb this phlogiston, which is why air does not spontaneously combust and also why plant matter burns as well as it does. As can be clearly understood, the wording in the above statement and other similar statements on phlogiston theory has created a number of possible suppositions and assumptions. A. In part, every combustible object was composed of phlogiston. B. Phlogiston leaves the object when it is burning and goes into the surroundings, air. C. The more intensely the object is burning, the faster the rate of phlogiston is released. D. An object that did not contain phlogiston or had released all its phlogiston would not burn. E. A specific volume of air had a limited phlogiston absorbing capacity. There are other possible assumptions, but those above illustrate the point. A key assumption of phlogiston theory was air attracts the phlogiston of bodies. This implies A. An attractive force exists between air and phlogiston. B. A pulling attractive force exists between air and phlogiston. Note, the pulling force was not considered or stated to be magnetic or electric in nature. C. Since every combustible material and living things are composed of phlogiston, there is always an attractive force between them pulling them towards each other. Further possible implications. 1. The less phlogiston the air has absorbed, the stronger this force of attraction. 2. The less phlogiston the air has absorbed, the greater the rate of phlogiston transfer. Can we measure point 2? Can these implications from phlogiston theory be used to support it? 1. The less phlogiston the air has absorbed, the stronger this force of attraction. 2. The less phlogiston the air has absorbed, the greater the rate of phlogiston transfer. Can point 2 be measured? Can point 2 be linked to point 1? I can measure the intensity of the light from the candle flame. The less phlogiston the air has absorbed, the greater the rate of phlogiston loss from the burning candle, and the more intense the light from the flame will be. Note: each candle, according to its size, wick size, etc., has a maximum light intensity. Reversely, the more phlogiston the air has absorbed, the slower the rate of phlogiston loss from the burning candle and the less intense the light from the flame will be until the air has absorbed the maximum amount of phlogiston it can, at which point the rate of phlogiston loss will be reduced to 0 and the intensity of the light will be reduced to 0. The intensity of light can then be linked to the strength of the force of attraction between the air and phlogiston and a mathematical relationship defined that includes the various factors involved. This can then be tested and refined. A chain of assumptions. Based on phlogiston theory and measuring the intensity of the light from the candle, the following chain of erroneous assumptions and suppositions can be implied. The brighter the intensity of the candlelight, the greater the rate of phlogiston transfer, so the greater the air-object phlogiston concentration differential, so the stronger the force of attraction between the phlogiston and the air. The chain of erroneous assumptions and suppositions can be reversed to: the stronger the force of attraction between the phlogiston and the air, the greater the air-object phlogiston concentration differential, so the greater the rate of phlogiston transfer, so the brighter the intensity of the candlelight. The erroneous wording used in the statement to describe the observation has 1. Created an assumed imaginary force of attraction that does not exist based on 2. Practical observations carried out that do not follow the scientific method. To be valid, the experimenter would have to manipulate the strength of the presumed attractive force between the phlogiston, which hasn't been proven to exist yet, and the air, even though it was thought at the time to be a single indivisible element. 3. From the observations which are invalid and do not prove cause and effect, a set of mathematical equations can be developed to express the presupposed cause and effect relationship between the force of attraction between the phlogiston and air, the air-object phlogiston concentration differential, the rate of phlogiston transfer, the intensity of the candlelight. As can be seen by this example of phlogiston theory, erroneous observation statements lead to genuinely mistaken beliefs. This phlogiston theory was believed and propagated by the influential scientists and teachers of the day for over 100 years, between 1667 and 1770. The phlogiston theory example proves that the scientific method must be strictly applied and adhered to prevent the establishment of incorrect theories. Would have the application of the scientific method prevented the mistaken belief of the phlogiston theory from being established and accepted and propagated? What is the scientific method? The scientific method is an approach to seeking knowledge that involves forming and testing a hypothesis. The scientific method provides a logical, systematic way to answer questions and remove subjectivity by requiring each answer to be authenticated with objective evidence that can be reproduced. The goal of the scientific method is to validate or invalidate the presumed cause of an effect. An experiment following the scientific method will feature an independent variable and a dependent variable. The independent variable is the presumed cause of the effect and is the factor which is changed between experiments, and the dependent variable, the effect, is what changes as a result. The steps of the scientific method. 1. Observe a natural phenomenon. 2. Alternate hypothesis. A. Independent variable, or the presumed cause. B. Dependent variable, the observed effect. C. Control variables. 3. Null hypothesis. 4. Test and experiment. 5. Analyze the observations and data. 6. Validate or invalidate the hypothesis. A hypothesis will now be put to the test. Applying the scientific method to the phlogiston theory. Air attracts the phlogiston, a fire-like element contained within combustible bodies which is released during combustion. 1. Observe a natural phenomenon, a forest fire started by lightning. 2. Alternate hypothesis, a tree burns, effect, because of phlogiston transfer from the tree to the air, the cause. A. Independent variable, the presumed cause, phlogiston transferring from the tree to the air. B. Dependent variable, the observed effect, the tree burning. The experimenter cannot manipulate or change the presumed to exist transfer of phlogiston in order to determine whether it is the cause of the effect and that it actually exists or happens. The independent variable is invalid, resulting in this experiment being null and void. Attempting to prove that phlogiston transfer is the cause cannot comply with step 2 of the scientific method. Applying the scientific method to the phlogiston theory. The hypothesis will be restated differently in order to try and allow it to comply with the scientific method. 1. Observe a natural phenomenon, a forest fire started by lightning. 2. Alternate hypothesis. The burning tree is losing phlogiston, the effect, because of the attractive force between phlogiston and the air, cause. A. Independent variable, the presumed cause, the attractive force between phlogiston and air. B. Dependent variable, the observed effect, burning tree, losing phlogiston. The experimenter cannot manipulate or change the presumed to exist attractive force in order to determine whether it is the cause of the effect and that it actually exists. The independent variable is invalid, resulting in this experiment being null and void. Attempting to prove that an attractive force is the cause cannot comply with step 2 of the scientific method. Also, phlogiston cannot be observed or measured leaving a burning object, so the effect cannot be validated. Applying the scientific method to the phlogiston theory, the hypothesis will be restated differently again. 1. Observe a natural phenomenon, a forest fire started by lightning. 2. Alternate hypothesis. The tree losing phlogiston to the air, effect, because it is burning, on fire, cause. A. Independent variable, the presumed cause, burning, on fire. B. Dependent variable, the observed effect, tree losing phlogiston and it transferring to the air. But phlogiston cannot be observed or measured leaving a burning object, so the effect cannot be validated. The dependent variable is invalid, resulting in this experiment being null and void and not being able to prove that phlogiston actually exists, let alone proving whether it is being transferred from the tree to the air. The light and heat leaving a burning object can be observed and potentially measured, but they are not phlogiston and they are not the cause or effect in the stated hypothesis. The hypothesis will be restated differently once again. 1. Observe a natural phenomenon, a forest fire started by lightning. 2. Alternate hypothesis. Light being emitted, the effect, because the burning tree is losing phlogiston, cause. A. Independent variable, the presumed cause, burning tree losing and transferring phlogiston to the air. B. Dependent variable, the observed effect, light being emitted by the burning tree. the hypothesis is malformed and invalid because the independent variable has two causes, not one. The independent variable can either be the burning tree or the transfer of phlogiston to the air. The experimenter cannot manipulate or change the presumed to exist transfer of phlogiston in order to determine whether it is the cause of the effect and that it actually exists or happens. The independent variable, the transfer of phlogiston to the air, is invalid, the experiment being null and void. Applying the scientific method to the phlogiston theory. Air attracts the phlogiston, a fire-like element contained within combustible bodies and released during combustion. No matter how the hypothesis is worded, the independent variable will be invalid and the experiment null and void, meaning that the independent variable, the presumed cause, cannot actually be tested to prove whether it is the cause or not. If the experimenter cannot directly manipulate and change the independent variable, then it cannot be proven to be the cause of the effect. A person may say, just because you cannot directly manipulate and change the independent variable, that doesn't mean that it isn't the cause of the effect. That is correct, but what it means is that it cannot be proven to be the cause, and so is just a belief. This leads to people mistakenly believing in non-proven ideas for long periods of time, as demonstrated by the example of phlogiston theory. Unless a proven cause is ascertained by the application of the scientific method, then the cause could be ascribed to literally anything a person wants it to be. For example, I could state that it is not phlogiston that is leaving the burning wood, but invisible unicorns. Unless the scientific method is applied, then unicorns have to be considered as viable a presumed cause as phlogiston or anything else a person wants to presume the cause to be. This indicates that if a theory does not comply with the scientific method, then it is no more than an unproven belief and is not factual or verifiable. The phlogiston theory example proves that 1. It is absolutely essential that a statement made regarding an observation must accurately describe only what is observed and not include any extraneous terms. 2. Any theory must be scrutinized by the scientific method to authenticate its validity. Despite the heat at the Hamburg conference, everyone burning one metal or another, I was able to discern the phlogiston as it escaped in the flames. There are those who do not believe. Ha! The accurate statement and application of the scientific method will now be applied to our original lead-aluminum mass observation. The accurate statement for the observation is: the dish of the scale with the lead block goes in the opposite direction relative to the dish with the block of aluminum of identical volume on when the observation is performed in the medium of air. But wording the statement in a different way, such as, the lead block is pulled stronger towards the ground, earth, than an aluminum block of identical volume, creates a number of new suppositions and assumptions. A. The block is pulled. B. Since it is now assumed that the block is being pulled, this then necessitates the presence or existence of a force. C. There is an attractive force between the ground or earth and the lead block. D. There is an attractive force between all physical objects. E. The greater the mass or stuff of two objects, the greater the attractive pulling force between them is. The wording of a statement about what is observed when two different materials of identical volume are placed on a set of scales implies the existence of a force. Remember, the phlogiston theory also implied the existence of a force, which was proved untrue and erroneous when scrutinized through the application of the scientific method. This implied existence of the force of gravity from the wording of the statement of the observation of the two masses will have to be scrutinized through the application of the scientific method to ascertain whether it is erroneous or not. Applying the scientific method to the masses observation. Why do things fall down when you throw them or drop them? The answer is gravity, an invisible force that pulls objects toward each other. Earth's gravity is what keeps you on the ground and what makes things fall. 1. Observe a natural phenomenon, a falling apple. 2. Alternate hypothesis. An acorn dropped by a tree squirrel will fall to the ground or earth, effect, because of the attractive force of gravity, cause. A. Independent variable, the presumed cause, the attractive force of gravity. B. Dependent variable, the observed effect, the acorn falling to the ground when dropped. Attempting to prove that force of gravity is the cause cannot comply with step 2 of the scientific method. The experimenter cannot manipulate or change the presumed to exist force of gravity in order to determine whether it is the cause of the effect and that it actually exists. The independent variable is invalid, resulting in this experiment being null and void. Applying the scientific method to the mass's observation. The hypothesis will be restated differently in order to try and allow it to comply with the scientific method. 1. Observe a natural phenomenon, a falling apple. 2. Alternate hypothesis. A dropped acorn by a tree squirrel will fall to the ground or earth, the effect, because of the mass of the earth, cause. A. Independent variable, the presumed cause, is the mass of the earth. B. Dependent variable, the observed effect, mass, acorn, falling to the ground. The experimenter manipulating or changing the mass of the earth is indeed an interesting proposition. The experimenter manipulating or changing the mass of the earth is not manipulating or changing the force of gravity in order to determine whether it is the cause of the effect and that it actually exists. The independent variable is mass of the earth. If it is then switched to include the force of gravity, this renders the experiment null and void. The force of gravity must be the only independent variable and be manipulated by the experimenter in order to prove that it actually exists and is the cause of the effect. A person states, but mass has or generates gravity, so mass, gravity, should be the independent variable. Before mass gravity is used as a valid independent variable, the person must first prove that mass has gravity. The scientific method will be applied to this assumption. There are two possible independent-dependent variable pairs. We will go through each pair in turn. Pair 1. 1. Observe a natural phenomenon, a falling apple. 2. Alternate hypothesis. An object will accelerate faster in a stronger gravitational field. A. Independent variable, the presumed cause, strength of the gravitational field. B. Dependent variable, the observed effect, rate of acceleration of the falling object. The experimenter cannot manipulate a presumed to exist gravitational field in order to determine whether it is the cause of the effect and that it actually exists or happens. The independent variable, the strength of the gravitational field, is invalid. The experiment is null and void. Pair 2. 1. Observe a natural phenomenon, a falling apple. 2. Alternate hypothesis. An object with a greater mass will accelerate faster towards the ground. A. Independent variable, or the presumed cause, mass of the accelerating object. B. Dependent variable, the observed effect, rate of acceleration of the falling mass. Current accepted theory is that all objects free fall at the same rate regardless of their mass, assuming appropriately fixed control variables. So, according to current theory, two spheres of identical volume but differing masses will have a similar free fall acceleration rate, implying that increasing the mass of the object does not cause an increase in the rate of acceleration. Also, the experimenter manipulating or changing the mass of the object is not manipulating or changing the force of gravity, so this experiment does not prove that the force of gravity is the cause of the effect or that it actually exists. A correct hypothesis with an independent and dependent variable cannot be formed to allow a valid relationship between mass and a presumed gravitational force to be established or proven. The presumed attractive force of gravity, like the presumed force of attraction between phlogiston and air, does not exist. Both attractive forces are created through the inaccurate and erroneous wording of observational statements that mistakenly generates a number of false assumptions and suppositions. The application of the scientific method proves that both these attractive forces are created through the inaccurate and erroneous wording of statements and are not real. In summary, the attractive forces of phlogiston theory and gravity were born from false assumptions and suppositions from the inaccurate and erroneous wording of observational statements. The demise of the presumed attractive forces of phlogiston theory and gravity occurs with the application of the scientific method, the arbiter of cause and effect. And mass, well, that is still waiting to be satisfactorily explained. And if you wish to apply the scientific method to dark matter, then good luck. Where does that leave this observation then? The accurate statement for the observation is, the dish of the scale with the lead block goes in the opposite direction relative to the dish with the block of aluminum of identical volume on when the observation is performed in the medium of air. Would the blocks accelerate in opposite directions at the same rate if the observation was carried out in a more dense medium of water rather than air? If the observation was carried out in water with a pine wood block and a wax block of identical volumes, what would happen? And if the scales were in liquid mercury? Can relative density observations comply to the scientific method? The next video awaits. My sincere thanks to Karen B. for her technical support in the production. Dedicated to John Levi, please check out the YouTube channel.